Okay, we wrap up section 2.5 by taking a look at some important application problems, growth and decay, and compound interest problems. Those are pretty important to our class. They'll show up again later on. So pay close attention to this. So first we start by looking at relative growth rates. Functions of the form y equals c times e to the kt, where c and k are constants, and the independent variable t represents time, are often used to model population growth and radioactive decay. Okay, two popular application topics. Note that if t is 0, then y is equal to c, just the constant c. So the constant c represents the initial population, or the initial amount that you start with. The constant k, on the other hand, is what we call the relative growth rate. If the relative growth rate is 0.02, for example, then at any time t, the population is growing at a rate of 0.02y persons, which is 2% of the population, per year. Okay, so that's what this relative growth rate tells us, how our population is changing, how it's growing. We say that population is growing continuously at relative growth rate k to mean that the population y is given by the model y equals c times e to the kt. So why don't we take a look at an example of growth and decay, and this will be atmospheric pressure. So the atmospheric pressure P decreases with increasing height. The higher you are, the less atmospheric pressure. So the pressure is related to the number of kilometers h above the sea level by the following formula. P of h equals 760 times e to the negative 0.145 h. What they want us to do is find the pressure at sea level and find the pressure when you're at a height of 7 kilometers, okay, which is pretty darn high. So how do we do this? Well, we have our formula for atmospheric pressure, P. All we have to do here is plug in the appropriate values. Well, when we're at sea level, the height is 0, so we plug in 0 into our formula, that's our input, and we just get 760 times E. Remember, the formula is this one that we're plugging into. So we're just plugging in for values of H. Okay, so in this case we plugged in 0, we get 760. When the pressure is, when we want to find the pressure at a height of 7 kilometers, all we have to do is plug in 7, and we get this expression, which we can calculate to be 275.43. Let me show you how to do this on your calculator. Okay, so what I want here is 760 times E, you could find right over here by doing second and ln, this key ln next to the 4. So you do second and ln to get e to the power of. And notice right away the calculator is just asking you to enter the power. Well, I'm going to go back to our problem and remind you the power was negative 0.145 times 7. So if we do negative, the negative is right near the enter key, right below the 3. And once again, the power is 0.145 times 7. So we do 0.145. I don't think I got the decimal point. There's the 0.145 multiplied by 7 in parentheses like this. Okay, and then we hit enter. And that gives us the 275.4258467, which in our notes we rounded up to 275.43. So that's how you would do this in your calculator. Okay, why don't we take a look at depreciation? So we've already seen a depreciation example in our notes before. Here's another one. It says a machine is initially worth V naught dollars, right? This is V sub 0, which we often read V naught, right? So V naught. This is called a knot. Okay? While this machine, however, loses 10% of its value each year. Its value after t years is therefore given by the formula V of t equals V naught, the initial value, times 0.9 to the power of t. You might be wondering, why is it 0.9? Well, if it's losing 10% of its value every year, then 90% of its value, or 0.9, is what remains, correct? So we do 0.9 to the power of t. Find the value after 8 years of a machine whose initial value is 30,000. Well, breaking this down, since you know that the initial value is 30,000, really what you know is that V naught is 30,000, and you're looking to see what the value is when t is equal to 8, because we have 8 years. So all we do is we plug those into our formula, and we get V of 8 is 30,000 times 0.9 to the power of 8, or 12,914. So 8 years later, because this machine depreciates in value by 10% each year, originally cost $30,000. 8 years later, it will cost $12,914. Okay, so that was a depreciation example. Here is compound interest. The really important topic in our class will be the topic of interest, and compound interest is quite important. So the compound interest formula that's given in your text is A equals P times 1 plus R over N to the power of NT. Here A is what we call the future value. Right? This is our future value. It's also called the investment. Future value, also called future value of the investment. P is the initial amount, all right, also called the principal. Initial amount or the principal. Okay. All right. So R is the annual interest rate, right? This is annual interest rate. And it is always given as a decimal, even though it's always going to be a percent. So this is a percent written as a decimal. Keep that in mind. Okay. And N represents the number of compounding periods. Okay, number of compounding periods. Compounding periods. All right. That's number of compounding periods per year, we should specify. Finally, T is simply the number of years. Number of years. So here's what this means. Say that you're putting money into a savings account. That's a good example to think of. The initial amount you invest into the savings amount is your P, your principal. Say you invest $1,000 into your savings account. Then they tell you what the annual interest rate will be for your account. And they give you that as a percentage. In our formula, when we do the math with it, is always going to be written as a decimal. Then they tell you what the number of compounding periods N is. In other words, how often will interest be calculated or compounded on your account? So will interest be compounded annually, which means once per year? Will it be, so annually means once per year. Annually is once per year. Will it be biannual, which means twice per year? Will it be quarterly, which means 4 times per year, every 3 months? Right? Or would it be monthly, 12 times a year? Right? 12 times per year. How many times in the year will they calculate interest on your account? Right? So the more, the better, obviously, right? And T here is the number of years. So if you invest the $1,000 after T number of years, given the R and the N, how much is in your account will be the value of A, the future value. Let's put all this to use in an example. It's the easiest way to see it. So find the amount to which $1,500 will grow if deposited in a bank at 5.75% interest, compounded quarterly for 5 years. So do this with me. Let's read this sentence and break the information down. Find the amount to which $1,500 will grow, right? So this is your P. This is the initial investment. Find the amount to which it will grow means find A. To which it will grow means find A. Okay. If deposited in a bank, 5.75% is your interest rate. So this is your R, 5.75%. But what did we say? We always write this as a decimal. Remember, percent simply means divide by 100. So 5.75% means 0.0575 as a decimal. You move the decimal 2 points to the left. Okay? And compounded quarterly, over here, simply means that your N is equal to 4. Finally, doing so for 5 years means that the T is equal to 5 in that formula. Okay, so put it all together now, and you will notice, using our formula, right, that we get A is equal to 1,500 times 1 plus R, which is 0.0575, divided by N, which is 4, to the power of N, which is 4, times T, which is 5. Right, that's what they have exactly here. Doing this calculation gives you 1995.55. So your money will grow to $1,995.55. Let's verify on a calculator. Right, so in the calculator I'll have 1,500. I'll open up a parenthesis here. And then remember, we had 1 plus another parenthesis for the fraction. Copying from here, 0575 divided by 4. 0575 divided by 4, close the parenthesis for the fraction, close the parenthesis for the entire expression here, to the power of 20. You do the little caret sign here to raise to the power to 20. And then you hit enter. And that's going to give us the 1995.55. Okay, and that's how it's done.